So here's a snapshot of Earth from NASA using infrared technology. Some of the things that you notice immediately. Where are the hot spots? Where are you losing the most heat? You're losing the most heat, for example, in the desert. Here is the Sahara Desert. Another thing you might notice is that the oceans, you're losing a lot of heat there as well. Interestingly, the clouds are actually a blanket. So these are equatorial clouds, and they're actually acting as a blanket. The ground underneath them, you can imagine, is actually warmer than these high-altitude clouds. So these clouds are actually protecting the Earth from losing heat. So here is the NASA readout over the last 30 years from that satellite. And you can see that the two are related. You can see that 10 years ago is still the hottest year, but you can see that they're not exactly the same. It's very difficult to understand why these two are not matching more accurately. This is one of the big problems right now in climate change, is to figure out why don't these two mesh better together. Again, we've got the highest point there 10 years ago. What's one of the big disadvantages with the space, the snapshot from space? One of the big disadvantages is that it only goes back 30 years. And we probably want to gather information about our climate going a lot farther back than that. So we're going to go back to the thermometers around the world, and we're going to go back to asking your friends in boats to give information, and we're going to go back 125 years. Okay, so here we go. I got my grandparents to phone on their cell phones to get this information. There's actually 3,000 surface-based thermometers right now. These are really high-quality thermometers. I'm just joking whenever I'm saying phone your friends. These are really high-quality thermometers. They stay in the same place, and they're very accurate. Here, what's the first thing that you see? As a scientist, you look at this and you go, there's something fishy here. And the fishy point takes place about 75 years ago. There's something wrong with this data. And so what we do whenever we come up with something like this that just looks wrong is we look for other data to try to confirm or to help us out. And in this case, we've got a little bit of data from boats that didn't mention, most of these boats, this temperature data is from the water temperature. But there were also boats that took information about air temperature. And it's that information that we're going to show now. And you see that doesn't have the sudden drop-off. What happened 75 years ago about that caused this drop-off? Well, it turned out that what happened was that about 75 years ago, the boats stopped using canvas bags, throwing them over the side and hauling them in. They stopped doing that because of World War II and submarines. They probably didn't want to be doing those kind of things. So instead, they started measuring the seawater temperature directly through the hull of the boats. And so that resulted in a 0.5 degrees Celsius difference in the two temperatures. So we have to correct this temperature data. We'll move it up like that. There it is. So that's the corrected. Again and again in science, you find that you have to figure out what's wrong with this data, and you have to correct it. Okay, let's go on. That's 125 years ago. You might see that there's a trend here. Looks like a global warming trend. It's certainly not a global cooling trend. And so let's just take a little while. Let's look at some of the possibilities that can happen with global warming. What can you expect?
Suntan.
Here we go. So, first thing is that you might expect that the ice caps might melt. So if that happens, well, then we can expect Florida to sink underneath the water. This is after 100 meters of water. This is after the entire Antarctic melts. That's going to take a while. Another possible outcome is that we might have improved trade in Canada's north and in Russia's north, because boats can now pass through ice-free areas. We might have droughts in various parts of the world, with famines associated with them and loss of life. We could also have beneficial rains and increased agriculture in some areas of the world. This is Cyclone Billy from a few weeks ago, and we might expect increased storm activity. We also might expect that diseases like malaria, which currently kill about 1 million children per year, that those diseases might infect more people in more polar latitudes. We also might expect that people in northerly latitudes might have a decreased incidence of death whenever winter sets on. Right now, you're more likely to die in the winter, on a winter day, than you are in the summer. So perhaps you're going to have a decrease in death rate with global warming. So let's look again at the temperature data. And this time we're going to go back. We're at 125 years. Now I want to go back even further. We're going to go back 2,000 years now. Now, how exactly are we going to measure the temperature from 2,000 years ago? Okay, so we've got the temperature up to like 125 years ago. That's not too bad. But how on earth do we go back 2,000 years?
Yes.
Now that is something to think about. Actually, what I'm going to do is I'm going to let you guys think about that question overnight. And you come back with ideas about how you might measure temperature over the last 2,000 years. This is the temperature that results whenever you do those measurements. But there is a lot of possibility of error. So these might be considered error bars. We're not sure that it's the black line. That might be our best guess. But it might be somewhere within this gray area. Here at the start, we're pretty sure, thermometers are pretty accurate, we're pretty sure that we've got it right for the first 125 years. But the farther back we go, we become less sure. For example, this is a smoothed version of what we have. For example, there's one group that believe that there's a huge warming in the medieval period around here, when the Greenland Vikings were established. A big, big warming. There's also another group that believes that there was no warming at all. And you can see that according to this person, we're at a very steady temperature over the last 2,000 years, except for the last 125 years. Okay, so your homework for tonight is to figure out how on earth you get that temperature data from the last 2,000 years. Got it? Okay, see ya.